Most of us look at buildings and we just see boxes, passive shelters that protect us from the weather. But what if that's completely the wrong way to think about them? What if a building isn't just a box, but an active, intelligent system that can actually work with nature instead of just fighting against it? Well, today, we're going to see exactly how that's possible.
Okay, so let's just jump right in with a pretty wild question. What if a building didn't need some huge energy-guzzling machine to keep you comfortable? What if its shape, its materials, even its position on the land could do almost all of the work for free?
The best way to get your head around this is to think of a building like a body. On one hand, you have the architecture itself. That's the skin and the skeleton, the form that actually meets the world. And then you have its metabolism, the mechanical organs and veins, like your furnace and air conditioner, that are constantly consuming energy. The whole goal of brilliant design is to make the architecture so smart that the metabolism can be as small and as quiet as possible.
And this brings us to the absolute first rule of sustainable design, the energy hierarchy. You see, you don't start by slapping solar panels on the roof. That's the last step. You start at the very bottom, with the climate. You have to understand the sun, the wind, the seasons of that specific place. Because here's the secret. Every layer you get right drastically shrinks the work the next layer has to do. If you nail the climate analysis and the passive design, you barely even need those active systems and renewables on top.
Now, this idea isn't some New Age invention. These principles are ancient. The ancient Greeks knew this stuff. As the playwright Aeschylus pointed out, a civilized society knows how to turn its homes toward the winter sun. The building isn't a passive box. It's an aggressive filter, precisely calibrated to let in the energy you want and block the energy you don't.
So, to see this aggressive filter in action, we don't need a futuristic skyscraper. Let's actually travel back in time to 1937 and look at a perfect example, the Schweiker House in Illinois. It was designed to be this finely tuned instrument for capturing the sun's energy. A total masterclass in passive solar strategy before the term was even a thing. The entire design of its main bedroom hinges on one single number, a number calculated with incredible precision for its exact location in Illinois. And that number is 24.5 degrees. So what on earth does that mean?
Well, 24.5 degrees is the exact angle of the sun at noon in Chicago on the winter solstice. That's the lowest it gets in the sky all year. The architect, Paul Schweiker, calibrated the room's depth and the window's height so that on the absolute coldest days, that low-angle sun penetrates all the way to the back wall, warming the entire space for free.
But here is where the genius really kicks in. That same design works in reverse. In the summer, when the sun is way up high in the sky, that perfectly sized roof overhang becomes a visor. It completely blocks the intense heat from ever even hitting the glass. So the room stays cool, all without anyone ever touching a thermostat.
Okay, but capturing all that winter heat is only half the battle, right? You also have to store it somewhere, and that is where thermal mass comes in. The best way to think of dense materials like concrete floors or stone walls is as a temperature battery. So during the day, that sun pouring into the Schweiker house is charging up the dense material of the floor. Then, as night falls and the air gets chilly, the floor slowly discharges that stored heat right back into the room, keeping the temperature stable all night long. It's a simple, powerful, and totally silent heating system.
Now, even with a perfect orientation, there's always a weak spot in a building's defenses. The windows. They are the thermal Achilles heel, basically a hole in the armor. In fact, they can be responsible for a staggering 60% of unwanted heat gain in the summer. It's a huge problem.
So how do we fix this vulnerability? Well, with some really cool modern tech called low emissivity, or low-E glass. The easiest way to understand this is what I call the sunglasses paradigm. Just like your sunglasses block certain kinds of light to protect your eyes, low-E glass uses an invisible metallic coating to block specific wavelengths of energy.
And this animation shows exactly how it works. That coating is totally transparent to visible light, so your view is perfectly clear. But it's reflective to long-wave infrared, and that's heat. So in the summer, it bounces the sun's heat back outside. And in the winter, it bounces your home's own furnace heat back inside. It's like a selective, one-way energy valve built right into the glass.
Okay, so we've got all these amazing strategies. But let's do a crucial thought experiment. What if we take a building facade designed for the freezing winters of Warsaw, something hyper-insulated, triple-glazed, designed to trap every single bit of heat, and we build it in the hot, sunny climate of New Delhi? What do you think happens? It's a complete catastrophe. A design that's a thermodynamic genius in one climate becomes a thermodynamic disaster in another.
it instantly turns into a greenhouse, trapping solar radiation and sending the cooling costs through the absolute roof. It is a visceral reminder of that first rule: context is everything.
And this brings us to a really important insight. In sustainable design, there are no universal solutions. There are only universal principles. The ancient wind catchers of Iran are just as brilliant a piece of passive design as a high-tech European facade. Each one is a perfect response to its specific climate. The right answer is always, always born from the place itself.
So we come right back to our hierarchy. By maximizing our passive design, by letting the climate and the sun's geometry actually shape our architecture, we fundamentally shrink the problem. We solve like 80% of the energy challenge before we even have to think about turning on a machine. And honestly, this is just the beginning. There are hundreds of these climate-specific strategies out there, from Trombe walls to solar chimneys. If you want to see a kind of global atlas of these brilliant ideas, a fantastic resource to check out is the 2030 Palette online.
So the next time you walk down the street, I want you to look at the buildings around you differently. Don't just see a collection of walls and windows. Ask yourself, is this building just a passive box fighting the climate with brute force? Or is it an intelligent, aggressive filter working in perfect partnership with the sun?